Hello students, in this video we are starting a topic on function for the mathematics of class 11. Function. A chapter on function. First of all, we shall take definition of a function. Definition of a function. We have already completed chapter on relation, so it is related to the relation also. As we have already seen, the relation is a subset of the Cartesian products of two sets A and B. Now here, a relation from a set, a relation from a set A to set B is said to be a function, is said to be a function if every element of set A, if every element of set A, every element of set A has one and only one, has one and only one image in set B. If f is a function from a set A to the set B, to the set B, and AB belongs to F, then FA is equal to B, where B is called image of element A, element small a under F, under F, and element A is called pre-image of element B under F. The function of the function f from set A to a set B is denoted as f such that from set A to set B. Once again, a relation from a set A set to B, a function if every element of set A has one and only one image in set B. That means if there's any element of set A which has no image, then that's not a function. Similarly, if an element of set A has more than one image in set B, that's also not a function. So, for a function, every element of set A must have one and only one image in set B. Then, therefore, the function f is a relation. The function f is a relation. The function f is a relation a from a non-empty set A to a non-empty set B, such that domain of such that domain of function f is set A, and no two different and no two different ordered pairs different ordered pairs ordered pair of function f has the same have the same first element have the same first element. That means all the first elements of set A should be different. If any even two ordered pairs in the two ordered pairs first element is same, then that is not a function. For example, number one, let relation R is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, where set A is 1, 2, 3, 4, 5, 6, and relation R is ordered pair XY such that Y is equal to X plus 1, and R is a relation from set A to the set A to set A. Here xy belongs to set A. Therefore, we should depict this relation by this figure A, A. We have 1, 2, 3, 4, 5, 6. Similarly, now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is set A and this is also set A. 1, 2, 3, 4, 5, 6. Now, element 1 is related to B. 1 is related to 2. This is R. 2 is related to 3. 3 is related to 4. 4 is related to 5. 5 is related to 6. Now in the definition, every element of set A first domain, every element of it must have an image in the second. If even a single element of first domain, this first set has no image in set B, then this is not a function. Now, since the element 6, since element 6 has no image, therefore R is not a function. Not a function. I hope it is clear to all of you that every element of this first set must have some image in set other set. All the elements of first set must have image in second set. In other words, all the elements of first set must be covered. All the elements of second set may or may not be covered. So that's why it is not a function. Then second example, let us take second examples. We have if R is a relation xy such that x is such that x is a square of y. Square of y. Let R is a relation from set A to set B. We denote this again. This is A, this is B. X is a square of y. Now we have here 9, 4, 25, and here we have 5, 4, 3, 2, 1, then minus 2, minus 3, minus 4, minus 5. X is a square of y. 9 is square of 3 and 9 is a square of minus 3. Similarly, 4 is a square of 2 and 4 is a square of -2. 25 is a square of 5. 25 is a square of -5. If you remember the definition of a function, every element of first set must have only one image. Every element of set this must have at least one image in set B. Now, because the elements of first set A have more than one image in set B, so this is not a function. Since the elements of set A have more than one images in set B, therefore R is not a function. R is not a function. No element of set A can be attached to more than one element of set B. But on the other hand, any element of set B may be attached to any number of elements of set A. That means all the elements, any elements of set B must have any number of pre-images in set A. But every element of set A cannot have more than one image in set B. So this is not a function. Then we take next example. Third, to make it clear, let us take third example. Third example, let R is a function from set A to set B, and R is equal to 2, 1, 3, 1, 4, 2. Now we can show this by figure, by diagram. This is A, this is B. A is 2, 3, 4, 2, 3, 4. B is 1, 2. Now 2 is related to 1. Then 3 is related to 1. 4 is related to 2. Now we can see that the no element of set A has more than one image in set B. No element of set A has more than one image in set B. Secondly, all the elements of set A must have images in B. There are two things. One is all the elements of A should be covered. Secondly, no element of A must have more than one image in set B. We don't bother about B. We are concerned with A. Once again, no element of A should be uncovered. That is, every element of this must have image in B. Secondly, no element of A should have more than one image in B. Therefore, since the elements of set A have images in B and no element of set A has more than one image in set B, therefore R is a function. So that's all. In the next video, we shall take graphs of the functions, different types of function, and also the algebra of the different function, different types of function. So please don't forget to like, share, comment, and subscribe to your YouTube channel Mathematics for Everyone to see more important videos. See you. Thank you. See you in the next video.